Hello students, come to the next lecture, Unit 4, large sample. So in this large sample containing 4 methods. What are those? Number 1, single mean. Number 2, two mean. And number 3, single proportion. And number 4, two proportion. So in those 4 methods, let's we discuss now the single mean. Now we'll go to the working rule of the single mean. Let a random sample of size n is greater than 30 has a sample mean x bar and population mean nu. Also, the population mean nu has a specific value nu naught. So, which is nothing but there is a mean of the population and there is a mean of the sample, and we are also having a size of the sample. Then we'll see how to find a solution for this. Step number 1 of the working rule, the null hypothesis H naught. It is saying that x bar equal to nu. So x bar equal to nu is nothing but, can I say the sample mean and population mean both are equal? Yes, because x bar is denoted by sample mean and nu is denoted by population. Yes, so both are equal. See here what it is given. There is no significant difference between the sample mean and population mean. There is no significant difference between sample mean and population mean, or the sample has drawn from the same population, so which is nothing but both are equal. And now alternative hypothesis is saying that whatever the hypothesis is there, that is opposite of null hypothesis. Okay, so in null hypothesis we are written as equal, right? X bar equal to nu. So in the alternative hypothesis we can say that x bar not equal to nu. Okay, and we can also say that x bar is greater than nu, x bar less than nu. So there are three different terms are there in the alternative hypothesis. One is not equal, and one is greater than, and one more is less than. Okay, right. Now level of significance, set the level of significance alpha. So it is nothing but this alpha in we seen in the last lecture, that is t distribution and capital F distribution. If we given alpha value in the question is okay, no problem. If we not given alpha value, then we know there is a standard value for alpha, I mean level of significance, that is 5%. Yes or no? Right. And now test a statistic. So it is nothing but whatever the data we are having in the question, that data we are testing statistically. Okay, so we are testing that given data statistically with the formula z equal to x bar minus nu by sigma by root n. Z equal to x bar minus nu by sigma by root n, where nu is nothing but sample mean. And now, so after getting the solution of this test statistic, we are giving a conclusion whether your hypothesis, I mean null hypothesis, is correct or wrong. So how we are giving the decision? Let's see here. If modulus of z is less than z alpha, then we accept the null hypothesis h naught. See, this will be accepted when modulus of z is less than z alpha. Okay, and we seen in the last lecture t distribution and capital F distribution, right? Now b, modulus of z is greater than z alpha, then we can reject a null hypothesis h naught. Okay, and here there are the standard values of the modulus of z alpha. There are the standard values of z alpha, and those are at 1%, 5%, 10%. And when the critical region not equal, I mean alternative hypothesis not equal, so these are the values we have to take at 1%, 5%, 10%. When alternative hypothesis is greater than, when alternative hypothesis is greater than, then we have to use at 1% 2.33, and at 5% 1.645, at 10% 1.28. When critical region x bar less than nu, then we'll use minus 2.33, minus 1.645, and minus 1.28. So this is about your working rule of the single mean. So let's go to the first question of the single mean. Right. So what is the first question here? A sample of 64 students have a mean weight of 70 kgs. Can this be regarded as a sample from a population with mean weight 56 kgs and standard deviation 25 kgs? So what are the values are given to you in the question? Tell me. Given you sample mean, and which will be denoted by x bar, right? So it is equal to 70 kgs, and sample of 64 students have a mean weight. So this 64 students of the mean weight is given to you 70 kgs. So it is nothing but, can I say this is sample mean only? Yes, because population size cannot be predicted or cannot be given in the question. Sample, I mean population size. The population size cannot be given in the question and cannot be predicted. This is the size of the population. Okay, right. So now, given you in the question, sample size n equal to 64, and also given you in the question population with mean weight 56 kgs. So population mean is given to you, right? So population mean new equal to 56 kgs. 56 kgs. Also given you a standard deviation sigma equal to 25 kgs. Okay, right. So these are the given values in the question, right? So let me discuss first of all what is the formula for this. Okay, so we know and we seen in the last page z equal to x bar minus nu by sigma by root n is a formula. Yes. So what is mean by x bar? And we seen in the last lecture t distribution and capital F distribution. X bar is nothing but sample mean, and nu is nothing but population mean. Sigma is nothing but standard deviation of population, and n is nothing but the size of the sample. Yes or no? So whatever the solution we want to find, those all the values are given to you in the question. Yes or no? X bar, n, nu, and sigma. These all the values are given to you in the question, right? So now I'm going to the working rule which we seen in the last page. So what is the first step? Null hypothesis, and which will be denoted by h naught, is saying that as per the working rule x bar equal to nu. So what is the value of nu here? X bar equal to nu is nothing but, then we have to write a value of nu. So nu equal to here how much we are having? 56, right? And now number 2, alternative hypothesis. H1 will be denoted by H1, and here working rule is saying that x bar not equal to nu. So can I say nu not equal to 56? Yes. So now step number 3, level of significance. Alpha. So did he mention the value of alpha in the question? Level of significance? No, right? I told you, when alpha value is not mentioned in the question, then there is a standard value that is 5%, and this we was seen in the last lecture. So then what is the value of alpha? 5% is nothing but 0.05. 0.05. Now my question here, did he talk about alternative hypothesis in the question? In the question, did he talk about alternative hypothesis? No, right? So when he won't talk about alternative hypothesis in the question, then I'm taking a standard format, that is x bar not equal to nu. When I'm taking as not equal, when he won't talk about alternative hypothesis in the question, then I'm taking as not equal. If we talking about alternative hypothesis, I as see greater than or less than, then that I have to mention in the question. So now he did not mention anything right about alternative hypothesis. So I took that as standard value x bar not equal to nu, right? So here, when a critical region not equal, see, now this is the value of alpha 0.05. Now we have to write a value of z alpha. We have to write a value of z alpha from this table. From this table. For that we are having 1%, 5%, 10%. So three columns we are having, right? So in these three columns, if you observe, one of the row nu not equal to nu not, and second row nu greater than nu not, and third row nu less than nu not. So my question is here, in alternative hypothesis, what did you take? Did you take in the alternative hypothesis as not equal or greater than or less than? Tell me, what did you take in the alternative hypothesis in the solution? You're taken as not equal, see. So then we have to consider the value of not equal row, critical region, nu not equal to nu not. So at nu not equal to nu not, what is the value of z alpha? 1.96. Okay, so I'm taking the value of z alpha as 1.96. I hope everyone is clear to you how to take z alpha value. Here z alpha values are fixed values, and those values we are taking from this table. Okay, so this table you have to remember, you are not allowed to take inside of the exam hall, this table only, in large sample table. But coming to the last topic, T distribution and capital F distribution, those tables we can take it inside of the exam hall. Okay, right? So now three steps are completed. Fourth step, that is test statistic, right? The formula z equal to x bar minus nu by sigma by root n, so which is equal to x bar is nothing but 70 minus nu is 56 by sigma is nothing but 25 by under root of n. N value how much? 64. Then by calculating, what is the solution we are getting here? 4.48. Okay, so this is the value of z. Therefore, what is the value of modulus of z? 4.48. So fifth step, that is conclusion. Or we can also say that the step number 5, that is decision, right? So what is the conclusion here? Here I got z alpha value 1.96 and modulus of z value 4.48. So in these two, which value is bigger? Tell me. Modulus of z value is bigger than z alpha, yes or no? So modulus of z value is bigger than z alpha. So what is the conclusion here? If modulus of z is bigger, then what can you say about the given data? I'll just show you once. I mean working rule. See what he's saying here. If modulus of z is greater than z alpha, we reject null hypothesis h naught. Okay. Then what can I write here? Hence null hypothesis h naught is rejected. Okay, it's clear everyone? Right, I'll give you a small conclusion. See, to finding a single mean, we required values in the question: sample mean, sample size, population mean, population standard deviation. So these four values should be given in the question. Then after getting these all the values in the question, then we are going to solving the working rule. So that is step number 1, null hypothesis H naught, and there is a standard value here, x bar equal to nu, and we seen working rule also, right? So what is mean by nu here? 56. Next, alternative hypothesis H naught, it is saying that opposite of alternative hypothesis, and moreover in this alternative hypothesis he did not talk in the question about alternative hypothesis, so that I took as a standard format, that is not equal. If he talking as greater than, or if he talking as less than, then that value I have to mention at alternative hypothesis. Okay, right. So here I'll show you one example question to you. See, in this example question, he given you in favor of alternative hypothesis nu greater than 332.6. So it is nothing but, can I say, in this question he talking about alternative hypothesis as greater than. So if he talking about greater than, right? So that I have to mention here greater than only. If you're talking about less than in the question, then I have to mention less than only. But coming to the first question, he did not talk about the greater alternative hypothesis. Either R is greater than, less than, or not equal. So as a standard format I took not equal. Okay, right. So it is not equal, then at 5% level of significance your Z alpha value is 1.96. Okay, then step number 4, test statistic Z equal to x bar minus nu by sigma by root n, and which is equal to, substitute the values and I calculated, I got the solution 4.48. Then step number 5, that is the conclusion. So what is the conclusion here? Modulus of Z value is bigger than this Z alpha. Yes, so then if modulus of Z is bigger, then whatever the given data, that data is rejected, that data is not supported up to the standard. Okay, right. So this is the solution of the first question. Now coming to the example, one more example to you. In this question, let's read the question properly, then we'll identify what is given in the question. In a random sample of 60 workers, the average time taken by them to get a work is 32.8 minutes with a standard deviation of 6.1 minutes. Can we reject the null hypothesis nu equal to 32.6 minutes in favor of alternative hypothesis nu greater than 32.6 at 10% level of significance? So it is nothing but, what are the values are given to you in the question? Tell me. In a random sample of 60 workers, so it is nothing but n equal to 60. The average in the sense, can I say the mean? Yes, average time taken by them to get a work is 33.8. So it is nothing but x bar equal to 33.8 with a standard deviation of 6.1 minutes. Sigma equal to 6.1. Can we reject the null hypothesis nu equal to 32.6 minutes in favor of alternative hypothesis nu greater than 32.6 at 10% level of significance? So in this question he giving you the value alpha as 10 percentage, and also given you population mean nu equal to 32.6. See, 1 2 3 4, and along with this 4 alpha also is given to you in the question. But if you observe previous sum, in that sum he did not give an alpha value. Yes or no? Right. So now I'll give you the small conclusion. I mean, how to find. See, alternative hypothesis is same. I mean, null hypothesis is same. Alternative hypothesis, he in this question, I mean, first question we are taken as not equal, right? But coming to the second question, we have to take as greater than. Okay, we have to take as greater than. Next, after that, we are taking level of significance alpha equal to 5% because he did not given in this question. So we consider. Then we are taking Z alpha value as 1.96. So coming to the second question, homework sum, I mean that example sum, 10 percentage, and here first row not equal, second row greater than, third row less than. So which will be considered here? Will you consider as not equal or greater than or less than? Tell me. We have to consider the value of this greater than, because in the question he mentioned alternative hypothesis as new greater than new not. Yes or no? Right. So that is the reason I'm mentioning in alternative hypothesis as greater than. Then I'm taking the value of z alpha also in terms of greater than only. Okay. So right, you can solve this question. Okay.